Welcome everybody. So today you came here to learn some iOS stuff, I guess. So let's start off with presenting myself. My name is Mike Seghers. I'm working as a consultant at IDA Media Foundry. I have experience in both Java and since 3 years in iOS. So first off, let me know also who does already some iOS in the room. Not too many. That's good because this is an introduction, especially made for Java developers. So since I come from Java as well, I should be able to explain you the differences between both languages. So if you want to tweet me, go ahead and add me as your as a follower. So at Mike Seghers. You can tweet me if you got questions. I will answer them via Twitter as well. So let's first look where does Objective-C, that's the language we are programming in if we are doing iOS. So let's first check a bit of the history of iOS, and then we will compare the two languages, so Objective-C and Java. Then we will start doing a lot of demos. So I will present an iOS6 example. We will familiarize ourselves with the Objective-C syntax. We will talk about memory management, and we will then make our first app. So by the end of this session, we should have a beautiful app. Well, let's hope. So a brief history. In the beginning, there was Brad Cox and Tom Love in the early 80s that looked to Smalltalk, and they liked it a lot, but they missed a bit of the power of C. So they built something over C, and they called it Objective-C. It was a small superset on C, but it made it object-oriented. So then later on, when Steve Jobs was fired from Apple, he decided to start this new company called Next. And he liked the way Objective-C was working, so he licensed from Stepstone, the company of Brad Cox. He licensed Objective-C, and so everything that he wrote, well, his team probably, was written in Objective-C. But they extended it a lot, so they added new features to Objective-C. We will cover those later. And he also added Foundation Kit. So like in Java, the Java util package, well, Foundation is more or less the util package for Java. Yeah? So they obviously didn't only take Objective-C. We know that Apple has always been keen on doing things graphically. So Steve Jobs also went looking to Xerox, and Xerox is the copier company, but they actually had a very nice user interface. So he licensed that as well. Too bad for Xerox, but Steve Jobs really made this happen, really made this beautiful. So he also has written this all in Objective-C, and, well, his team again. And in came AppKit, and this is known as Cocoa. So who has heard of Cocoa before? So that's the user interface you get on Apple. So Cocoa becomes the de facto standard on Apple. So after a few years, Steve Jobs re-enters Apple, and of course, when you buy Steve Jobs, you buy everything he bought as well. So licenses from Objective-C and the Xerox company came into Apple, so Steve Jobs could use this for Apple. In the mobile era, Steve Jobs was again a pioneer. I believe we can all say this. Even if we love Android, still we must give credit to Apple for introducing a well-thought-of platform. But they already had a lot, so what they only needed to do, well, it's a lot of work, obviously, but the only thing they needed to do was port AppKit to UIKit and Cocoa to Cocoa Touch. So, and in came the mobile revolution, right? So some facts, fun facts about Objective-C. Objective-C is apparently the 10th most popular language on GitHub. In perspective, Java is number 4 and JavaScript is number 1. Then you have the TiOE reference. There, Objective-C is number 3, and this looks at search engine hits on Objective-C. So we are number 3. Java, again, beats us with number 2, and C, strangely enough, C is number 1. And for the gamers between us, the Doom level editor, way back, was written in Objective-C on a next computer. So you can do powerful stuff with it. So let's move on to comparing Objective-C to Java. So first off, in Java we have these namespaces called packages. These we don't have in Objective-C. So to make classes unique, we use prefixes. You will see in this presentation as well a lot of prefixes starting with NS. This is an abbreviation for next step, coming from Stepstone and next put together. So this is the foundation kit. And then UI kit is prefixed with UI, and there's many more examples. So every framework you use in Objective-C normally has these prefixes to make sure that we more or less can be sure that something is unique. So no packages here, but another trick to do the job. It's by convention, so you have to know what is already in the Objective-C world, not to make duplicates. A big difference between Java and Objective-C is that Objective-C is a dynamic language. So a dynamic language, that means that you can, for instance, pass method pointers. We will talk about pointers a lot in this session. But you can pass method pointers. So the closures we are waiting for in Java actually existed since a long time in Objective-C, since it's a dynamic language. With that comes that there is no real type safety, so the compiler will warn you in great amount about things, but it will be warnings. It will not be errors like in Java. So that's a big difference. So like JavaScript, who knows JavaScript here? You all know that's a dynamic language. You can just add in methods on the go. Well, in Objective-C you can do the same thing. So a method call is called a message in Objective-C, so we still talk about methods, but when we call a method, we actually send a message to an object. In Java, this is all done at compile time. It's static, again. In Objective-C, this is dynamic. And that's a big difference. For us developers, most of the time, it seems like we are doing a method call like we are doing in Java, but it's important to see that there's a small difference. When we call a method, we send a message to an object in Objective-C. So it might well be that you are sending, let's say that our message is an envelope with an address on it, but it can well be that address doesn't exist or doesn't respond to your envelope. Yeah? So things need to be done to make sure that when you call a method, that the method exists on the object, and this is done at runtime. If you do things wrong there, you will get exceptions. The compiler takes care of a lot for us, but if you go a little deeper, we will need to make sure that we are doing things right. I will give an example in the demo. So then interfaces exist as well in Objective-C, but not as we know them as a Java developer. An interface actually is just a definition of a public interface. Like in Java, you would say, but it's not like in Java a contract. Yeah? It's just making things visible to the world. A protocol is what we know as an interface in Java. A protocol is something that makes up a contract between a class and an interface. So something very specific for protocols. You know, in Java, if you have an interface and you implement the interface, you have to implement all the methods on that interface. In Objective-C, this is not the case. If you have a protocol, you just adopt, we say we adopt a protocol in Objective-C, you adopt a protocol, and everything that's optional, you can mark that as optional, you don't have to implement. Again, you will have to do some runtime checks to see if the implementer or the adapter of your protocol is really implementing the method. So that might look strange in the beginning. Then the interface implementation is a protocol adoption, as I said, and a class adopts a protocol when it defines the fact that it adopts the protocol and that it implements all the required methods. So this is a lot of theory for now, but this will become clear in the further presentation. What we know as this in Java becomes self. It's just another word, but it does exactly the same thing. It gives you a reference to your own object. So this is self, and super stays super. So that's something we don't need to learn. So just remember, this is self. We also have import statements, like in Java. The import statements make sure that you can use other classes in your own class. Include exists as well, but I advise strongly against it to use it because it doesn't take care of duplicates. So if you have two code blocks and one of those code blocks already includes a code block that you include in this other one, you will get duplicate definitions in your compilation. So basically, the compiler won't be able to compile your code because he has duplicates. Then null actually is called nil in Objective-C for Dutch-speaking. Who is Dutch-speaking here in the room? So this resolves the null-null paradigm in Dutch. People speaking Dutch know what I mean. So in Objective-C we call it nil. So it's directly clear, it's N-U-L-L. There are aliases. You can do it in capital case, small case. And actually 0 can mean nil as well. So that's all nil. A small thing about the nil value. In Java, if you call something on something that's null, you will get a null pointer exception, right? Well, that doesn't exist in Objective-C. Objective-C just returns a default. So if you call a method and that method returns an object, and you call the method on an object that is nil itself, well, nil is returned as well. So no null pointer exceptions, but of course, again, if your entire flow depends on something being filled in, you might better do the check because of performance, yeah? To avoid that the rest of your code blocks is called. But you will never receive null pointer exceptions in Objective-C. If the method returns primitive types, 0 or 0.0 is returned, depending on the type that is returned. So also for booleans, a boolean doesn't really exist in Objective-C. There's an alias for it, but a boolean really is a character, and false is 0, and all the rest is true. So you can shortcut some if expressions in Objective-C as well. You don't always have to compare, is it equal to null? You can just write the variable. Then primitive data types. Since Objective-C is based on C, your primitive types are also dependent on the processor you are using. So that leads to sometimes to some confusion. If you have a 32-bit processor or a 64-bit processor, your longs or your integers might be larger. So people already, who did some C in his career? Yeah, okay, enough people, so you know what I'm talking about, right? So again, the Boolean is not a real data type. It's just an alias. Then to top it off, the differences between Java and Objective-C, because then we had them, the differences, then everything is, well, practically the same with a different syntax. So let's look at strings. Strings is a special case. Since we extend from C, and C already has these character pointers, yeah, Objective-C needed another syntax, and that's why you see the little add sign. Yeah. Add means that this is an NS string, so this is a class coming from Foundation. You can notify the NS, that's the prefix. So NS string really is an Objective-C object, while character pointer is not an object. So This will feel a little bit strange in the beginning. Your strings, you have to add the sign, okay? So, like in Java, and a string is immutable. We have also a mutable version, but we will talk about that later. So things that don't exist in Objective-C is abstract classes. They don't exist. You can mimic their behavior at runtime, but still you won't have compiler errors to tell you that you still need to implement one or other method. So abstract classes don't exist, so don't go looking for them. They're not there. So, and generics. We are missing generics in Objective-C. Too bad. So now let me present you, because this was a lot of theory, so let's do the fun part now. Let's switch to iOS 6. So this talk is based on iOS 6 and uses some of the newest features of iOS 6. And I prepared for you the Big Bang app. Who knows the Big Bang Theory? Quite a lot of you, that's good. So the Big Bang Theory is actually a sitcom, an American sitcom I like a lot, so I based my presentation on those guys, since they're nerds as well, okay? So, but actually what does the application do? Well, it's a master detail app, so you will get a table view, and if you touch the table view, you will see the detail about the person, and actually there's two detail views put in a tab view. So you will get an image and some more info about the person. So let me show you the Big Bang app. I have to put this here, like this, okay. So the Big Bang app is this table view. When you click up a person, let's take Sheldon again, you will get some info. If you click the image, we will see Sheldon. And if you click here, we might not come to this example due to lack of time, but if we can, we will see that we can, if possible, go to the website. But Sheldon doesn't have one to show you that you can give alerts. Leonard has one, so this will skip to the wiki page of Leonard. So that's the example app we will be doing in the coming 163 minutes. So switching back to the presentation, the demo I already gave. Let's look at the model. So like in Java, we try to separate some things. It's object-oriented, so we still have layers. And for this app, it's pretty simple. A person actually exists with an identifier, a name, a last name, a real name, profession, bio, image name, and website. All strings, to make it simple, okay? So that's the simple model. Now, how do we make this class? So first off, like in C, you have header files and implementation files. The header file is where the interface, the Objective-C interface, so don't think about interfaces in Java, it's something different. So you have the header part and the implementation part. The header part holds the visible API. I will talk about visibility a lot in this talk, because private is something different in Objective-C. Real private, there is some, but not too much. Most things are just invisible. Yeah? So we have the header file, we have the implementation file, and then something different from Java as well is your file names don't have a constriction like in Java. In Java, you have to name your file as your class. Well, this is a convention in Objective-C. We do this as well in Objective-C, but you are not forced to. Actually, in Objective-C, you can have many class definitions in a header file and many implementations in an implementation file. But obviously, that's not well-structured code. But it is possible, and sometimes it's handy to have this feature. So the file names are named after their classes. So in this case, we will make a person.h file and a person.m file. So in the person.h file, we will start with an import. And normally, you import a foundation. So this is this NS things. We will cover them a lot in the remainder of the talk. So we will import in the header file some things that we will need, both in the header file and in the implementation file. Then we define an interface. So again, not a Java interface. We define an interface and we call it person. So this is our class name, the person class. And then we say that we extend from and as object. I will talk about extension later in detail, but for now, already know that you have to extend yourself. Not like in Java, you automatically extend from object. You don't in Objective-C. So you have to extend and as object, and we don't use the extend keyword, we use the colon symbol. And then for the implementation, so that's in another file, we import the header file, our own header file. Yeah? And then we have the implementation block. So that's a little bit different from Java, right, the syntax, but it's just getting used to. Yeah? In the beginning, this will be strange. So let's go and do a little demo. I will switch screens now. If I can find my mouse pointer, I don't know where it is. It's gone. So let me go to synchronous. And then normally you guys should see my Xcode. Yeah, great. Okay. So first off, let me start an entire new project. So in Xcode we do this in the file menu. You can go to new and then create a new project. If you are coming to the hands-on lab, we will do this all ourselves in much more detail. So do come to the session this afternoon if you want to get your hands dirty. So let's create an empty application. We could go for master detail, but that would already implement too much of the code, so that wouldn't make a great demo. So I'm starting with an empty application, and I will call it Big Bang App. Okay. For now, take from me, I will just make it for iPhone, and these checkboxes I will explain later. I'm just going to leave them as they are. Then it comes ask me for a location. I'm happy with the location it presents me. So there you go. I have my first application up and ready. So I can already click play and something will come out of that. Yay, a blank screen. Yeah. So that's my empty application. Now let's say that we are not going to support orientation switches just for now. That would make the demo too complicated. So let's stick with the default portrait orientation. And the rest of this, the things that it generated, we will look at it later. But for now, we are going to make the person class. So let's first organize our code a bit. You will see that Xcode organizes your code. Basically, this is not backed by a folder structure. It's just an XML file in the back. So you don't really have, since we don't have packages, you don't have this folder structure you have in Java. Basically, it's up to you to organize your code yourself. So let's do that a bit. Let's create a new group, and we will call the group model, because this will be the model group. Okay, and then we will create a new file. It's an Objective-C class this time I need. And we will create a person. So person, don't type the .h, it will do it for me. And my subclass, of course, will be an as-object. So I will create this in my project folder. And there we go. Xcode already generates for me the header file. And it generates for me the implementation file. We will fill this up in a minute. But that's making a new file in Xcode. Let me switch back to the presentation. Yep, there we go. So method syntax. This is very, very strange for all of you, probably. All those that didn't do iOS already. The method syntax is very strange in Objective-C. It's getting used to. So we tend to think that in Objective-C method names are strongly named. Why is it strongly named? Because actually in the method name itself you specify the parameters you need to pass. So I have this little example. We think, therefore we exist, and you maybe, yeah, it's visible enough. You see the colons. The colons are very important. So they are the separation. You know that there will come a parameter. And the parameter is something to do with think. the first one. And the second one has something to do with for. And the last one has something to do with exist. This is very abstract, but I will demo it later on. So this looks very weird. You will the first few times you will say, what's this? Yeah. So the method syntax is very specific. Then let me talk about method visibility. So in Java, you know that we can make things private and we can make things public and we can make things protected and we can even make it package private. Obviously, we don't have that one in Objective-C, but we don't have the protected and we don't really have public and private neither. We only have visible and invisible. Invisible, you don't put the method in the header file, basically. Visible, you put it there. So the header file is what gets included in other people's code. And if you don't put the method in the header file, the other developer that is using your header file won't know that the method exists. But it's still there and he still can try to call it and he will be able to without exceptions. So that's something you need to think of when you are doing Objective-C. You're hiding methods, you're not making them private. Again, due to the dynamic nature of Objective-C. Static versus instance methods exist as well, but the syntax is a bit different from Java. In Java, you note it with the static keyword. In Objective-C, you make the difference with the plus and the minus sign. So in the method signature, if you put a plus in front of it, it's a static method. Otherwise, it becomes an instance method. So let's look at a little example here. I've prepared two methods for you guys. The first one is a static method. So why is it static? Because there's a plus sign in front of it. Then we have the return type, in this case a person itself. So you can return yourself. And then this is our method name. So two parts there. So the method name actually is person with name and last name. So I don't know if you mentioned already, but this is very clear. In Java, typically we would have a person method and two parameters, but there's no real naming for the things you expect. You will just pass strings, and hopefully you have a good IDE that helps you with what exactly do I need to pass in. In Objective-C, it's much more clear. C, the first parameter is the name, and the second one is the last name. So that's, I think it's nice. It's getting used to, but it's nice. After the method name comes the parameter type, so in this case, and then a string, and then the argument name. So don't confuse the argument name with the method name. The method name is just to signify what you need to pass. You still need good names for your arguments as well. Yeah, then I skipped too early. Let's see at an instance method. So the instance method is noted with a minus sign. So you will need an instance to call this method. And then you can also obviously have methods without any parameters, so you don't see a colon neither. So that's it. Then the method name, again, you have two colons in this case. So two colons means two arguments. Yeah. And then the types are not taken into account, so don't bother with also adding a string or something there. It should be clear from the model that the name is a string and the last name also is a string. So then the method implementation. So the implementation goes in the implementation file. So you put it in the .m file. And you basically just repeat the method definition you have in your header file. You take away the semicolon and you add braces. And we're off to making a method. So the syntax here is not that different from Java. The only difference is the return type is put in parentheses. You have this little minus sign in front of it. But for the rest, it's pretty much the same. And also, like in Java, the accolades, so the braces, they limit scope. So that's your scope limiter. Just like in Java, it works just the same. So if we want to call this method, and this is again a little bit different from what we do in Java. In Java, you just say person dot get full name, right, and you have parentheses. While in Objective-C, we do this with square brackets. So that's getting used to as well. So you start with the brackets, and then you mention the object or the class if it's a static method on which you want to call the method, and then you will do the method name and you pass the parameters in. So brackets, the object in this case, the full name, we want to call the get full name, so we do. And here we do the class name because it's the static method. We have again the method name, and in between you put the parameter. So who thinks this is strange? Yeah, you should, because it's strange. It's getting used to. It's every time you learn a new language, you will have to learn these specific things, and Objective-C is a little bit specific in these parts. So let's start by adding some methods to our person. So I will add now these person methods in the code. So switching back to Xcode, I will start off with a header file because I want to make them visible, these methods, so everybody can use them. So I will start off with a plus because I want to make a static method. My return type will be person, and I will create a method called person with name, which takes in a string, and the name of the parameter is name, and then let me see, and last name, and a string again, last name, and then the semicolon. So this is my method definition. It's like an interface in Java really, but it's not the same contract, so don't confuse the two again. So then an instance method, so I start with the minus sign, the return type will be and then a string again, and I will call this get full name. So obviously this method is going to concatenate the last name and the first name together into a nice little feature. So then for the implementation part, and this is where Xcode is going to help me a lot. So I start off with telling Xcode I want to define a static method, and then I just start typing. I do person, and Xcode, since I already included in my header file, Xcode will tell me, okay, you probably want this one. So then the implementation I will do later, but I need to return something. So let's for now just return nil. And then for the get full name, I will return a string, but for now, since we don't have the variables yet to do it, for now we will just return full name. Again, make sure you add the @ sign. If I take it away, normally Xcode will start complaining. You see the warning. Okay. So there we go. That's making methods. So switching back to dual screen. And switching back to, I hope, to Keynote. I hope, to Keynote. Okay, so we made some methods, we made a class, we made some methods on it, but there's nothing that we could do yet because we don't have properties yet. And like in Java, properties are really things that normally are accessible through getters and setters. But there's a very specific syntax again that helps you quite a lot. And this is a nice feature in Objective-C. You will love it. Because in Java, we still need to generate the getters and setters ourselves. In Objective-C, this is all magically done for us. Yeah. Of course, you can override, but normally the standards is enough. So properties provide a simple way to declare instance variables and accessors, so getters and setters. They are declared in the interface block and they are synthesized. Yeah. So that's a new term. They get synthesized in the implementation block. So what does this mean? So here you see the person with a property of type and a string name. So this is how we write that piece of code. So we start with the add property, and then we say the type of the property is and a string pointer. We will talk about pointers later, so take this for now. And then we have the name. Okay. And then what we do in the implementation part is we synthesize this property. So we do add synthesize, then name, and then equals underscore name. But this you can already forget. because since Xcode 4.4 or 5, this is done automatically by the compiler. So you don't even need that synthesize line anymore, just the property is enough. So what synthesize actually does, it's important to know what it does, even if it gets auto-generated. It creates the getter and the setter name. But I made a little error on the first example, actually. In Java, a getter is get and then the name of the property, right? While in Objective-C, it's just the name of the property. You don't have the get. Yeah? The set method is like in Java. So there you will put set. That's the default. You can override, we will look into that later. So since Xcode 4.5, it's synthesized automatically. Now, to work with properties, this is, again, a little bit special. So we know now that we have a name method and a name method and a set name method, but we can call this in a specific way in Objective-C. Instead of using the bracket notation, you can now use, since it's a property, you can use a dotted notation. So again, this is a bit strange because I came to tell you that, well, methods are called without a dot and with brackets. Well, in this case, with properties, you can shorten that and you can use the dotted notation. So, and they work, the dotted notation works in both ways. So look at for the getter, it's person.name. For the setter, again, it's person.name, so don't put set there. You just say person.name equals. And basically what the compiler will do is it will translate that for you to the lines that are above it. So you will get person set name, but in a much shorter syntax. So let's add some properties to our class. Again, switching to Xcode. There it is. Let me close some windows so my code becomes a little bit clearer. So yeah, obviously I need to take the header file first. So I will take the header file, and what we normally do is we define our properties above the methods. Again, you can choose, but I like to do it in this way. So we will start off with an add property, and then a string. This is my type, name. Yeah. So I define the property now. And I will repeat the process for all my other model objects. So we will have last name identifier. I'm doing this out of the top of my head, so I might miss one. Real name, we had bio, we had, let me check, bio, name, last name, real name, profession, no, didn't have that one yet, profession, the image name, and then we still need the website. I might miss something, but I will add it later then. And in the person.m file, I don't need to do anything anymore. It's automatically synthesized for me. So this means now that I can probably already do this get full name method. Yeah? And let's rename that. Let's already say it's full name. Yeah? But this is not a property yet. We will transform it to a property later on when we talk about attributes. But for now, let's already rename it to full name. And what we want to return actually is the concatenation of the last and the first name. So in Objective-C, we do this with the NSString class. There's a static method on it. It's called string with format. And the format, just follow the example for now. The format looks like this. So this means I'm going to make a string with 2 objects in it. And the objects are going to be strings as well. So what I will add is, and now I can use this, self dot, because it's a property of myself, self dot name, self dot last name. And then I still need to add the brackets in the right place. So that's here. So this is a method call to an NSString method, string with format, and I will pass in self.name and self.lastName as a format. Yeah. So now the full name method will at least give me something back. Yeah. Let's wait for the person with name a little longer, but you will see there that we will use the self.name equals name to set the name. Okay. The name. Okay. So that's adding properties to a person. Let me switch back to the presentation for you guys. There it is. Then creating the object instance. So now we created a class, but we still didn't see how do we construct, like in Java with a constructor, how do we do this in Objective-C? And this is again a little bit specific. Basically, if you make an object in Objective-C, you will need two steps. You will first need to call a static method, which is available on all NSObject extensions. So basically, too fast. Basically, you will need to call alloc. And alloc says, allocate some memory for me. And allocate the memory for this class. So automatically, the memory will be large enough to contain your object. And then you need to send an init method. So again, this is very specific. You get used to it very fast, but it's specific. You just don't do new. Well, I will tell you that there is something like new, but you shouldn't use it. So let's look at an example. First off, an init method, again, very special, returns ID. I will talk about ID later, so take this for now. It returns ID, which basically means everything. But we will cover this later. So the method name is init, and the first thing we do in an init method is we call the super designated initializer. The designated initializer is the by default the preferred initializer of your superclass. So this is very special. Yeah, this is Objective-C. In Java we don't need to do these things, right? So again, special to Objective-C. So you assign self to the call to super init. And then you check if self, referring to the nil, if something goes wrong, the contract says that if your init method does something wrong, you return nil. So here we can check if self, so that means if self is not nil, that's the same thing. So if self exists, then go ahead and do my construction of my object. So put some default values or I don't know what, but that's what you can do. And then you return self. Yeah? Very specific. I know this will probably, again, look weird, but you have to use this one in Objective-C. So we call it the alloc init paradigm. You always need them together. Obviously, you can have more than one init method. You can have init methods with parameters, but you will still need to call alloc first and then do init. You also have the static new method, but you shouldn't use it. It's only capable of using your init method and not anything else. And it makes your code really, for Objective-C developers, it makes your code look weird. We are used to doing alloc init, so do that as well. Don't use the new. Another way to create classes, and basically I already started with doing one, is convenience methods. A bit the same like in Java with builders. If you have a builder, well, in Objective-C we will put some build logic inside our own object. So they are static and they create the object for you. So let's add an init method and let's add a convenience method to our code now. So, going to Xcode, let's first start with the init method. And I'm going to be lazy a bit, because the init method will also initialize my person using exactly the same parameters as my convenience method. So, let me put that probably a bit down here. Doesn't matter that much. So, we return ID, and then we do person, and let me see, yeah. Already too much. So not person obviously, but init with name and last name. So I created the definition of my init method with parameters. I still, I missed the semicolon. I still have the init method because the init method comes from NSObject. So I can still do just an init without passing last and first name in. but that already exists because I extend from and as object. So now, again, let's use Xcode a bit. If I type init, it will present me a code snippet. I can just enter it, and it will generate that difficult to repeat thing for me. So use it, just type init, and I'll let Xcode complete the code for you. The only thing I will need, obviously, is I will need to add parameters. So I have this with name and last name, so let's use it. And now just let assign self.name equals name, there you go, and then self.last name, and again assigning the parameter that is passed in. You get this? Can I get a yeah? Yeah, okay, very well. So now we have this init method, so I can go ahead and use this in an alloc init paradigm, but I can also make it convenient for the users of my class. Instead of making them write alloc init, why not also provide a static method that does exactly the same but for them? So let's write this. Let's do person alloc. So this is my alloc. And then init with name. So I just pass in name and last name. There you go, last name. There you go. By the way, Xcode will help you with the brackets and things like that, so it's not that hard to get used to if you use Xcode. Okay. So now I am returning actually a person that I created for the user of my class. So he doesn't need to do the alloc init with name and last name. He just needs to call on person with name and last name. That's easy, right? So this is how you make it easy for the user of your classes. That's a convenience method. So switching back to the presentation, let me have a look. Memory management. A big hassle until a half year ago. So what is memory management in Objective-C? And this will be hard, but you can forget it after these slides, because you won't need it anymore. Well, if you start with iOS. If you go deeper, you will still need it, but for now, take it from me that if you do alloc, what we get is a retain counter on the object. So that's something that's on an object by default, and the retain counter is set to 1. When it drops to 0, automatically Objective-C will destroy the object, so it's gone from memory. If you still try to call something on that method, you will get exceptions. Yeah? On that object, sorry. So if you do alloc, you will get a retain count of 1, and obviously you can also call retain. If you retain it, that counter gets augmented. In this way, other object can take co-ownership of this object that is passed in. So that's retained for you. You can also copy, and copy is really creating a new instance. So again, the retain count will be 1. Then later on, you can release. Each time you release, you subtract 1 from the retain counter. And then at last, if you do the last release, it will become 0. And then you cannot use this instance anymore. If you try to call a method on the instance, you will get ugly exceptions, and they are not readable at all, and you will be in trouble. That's why I included the meme. So you will detect memory leaks because you didn't release enough. Then you will try releasing in some place because you don't really know what you're doing, and you will release too much. And then, yeah, things go bad, and you have a bad experience with Objective-C. But since 4.1, we have automatic reference counting, so ARC. And what ARC does is all these weird things with retain and release and auto-release and copy, it manages it for you. So the compiler will actually add the code for you. The code is still there, but you won't see it. You don't need to do it. That's why in my examples, I didn't have retain, I didn't have release. I don't have to think about this anymore. I just use ARC. So please, as a beginner, do use ARC. Because memory management is often complicated. It follows general rules, and once you get used to it, okay, it's okay, you won't make errors anymore. The only thing is you will still forget to release in some place, and you will get memory leaks. So use ARC. And ARC, in Cocoa for Mac OS X, you have garbage collection. Well, garbage collection is deprecated from Xcode 4.2. sorry, from 4.2, they also prefer Arc on OS6 even, because it's much more performant than garbage collection. So there you go, Arc, it will help you a lot. So now that we've seen a bit about memory management, we can look at the details of properties again. Because obviously, if you take a property in from somewhere else, you probably want to retain it. You probably don't want somebody else to destroy the object. You want to also be able to say, I need a strong reference to it. So this is, in Java, this is all automatically. You don't have to think about it. Well, in Objective-C, you still need to think about it a bit. Yeah? But it feels natural. If you take ownership, you make a strong reference, otherwise you make a weak one. So let's look at these property attributes. A property attribute, well, basically modifies the way a property behaves. So it affects, for example, the names of your getters and setters. It makes it writable or read-only. So we can have a property that's only read-only. The inverse doesn't exist. Only writable doesn't exist. And it will do something with the atomicity of things. So that's important when you think about threads. So method name attributes, first off, so we will now modify the getter and the setter, just for the example, because basically you never need to do this. I don't see the example. But you can, just to give you the chance to do so. You can say my getter will be called my custom get instead of my float property, which is basically wrong because it's a string. I need to correct that one. And the setter is set custom in this case. So again, this leads to very unreadable code, so don't use it. Yeah? But you can. Just to be complete, I put it in there. To say something about the writability of your properties, so to make it immutable, you can set it read-only. And automatically, the synthesize will know that it cannot make a set method for us. Yeah? It will only include the get method. So then, and this is a little bit harder to understand, here we will add the arc or the memory management attributes. So in the first example, we have a strong reference. So that means that our string will be maintained in this class we are passing it to. So if I destroy the string, which I just passed, the other class will still have a reference to it. And you won't get into trouble. At the other hand, sometimes you have retain cycles. The one retains the other retains the one. So then you have this cycle. So in this case, you will need a weak reference. And you will have to make sure that you destroy the object for the other class. This is a bit the same thing with event listeners in Java. You also need to remove yourself the event listeners. So that's the same thing. You are responsible for making this weak link work. But since Arc, it's easier, because if it's a weak link, it will not remove the object just until the object which is used in the other class is turned to nil. And we know if you call something on nil, well, basically nothing happens. So that fixes a lot of errors as well. You will not get the result you expect, but you won't crash the application, which is important as well, obviously. Then copy, that makes a copy. So if you pass in a parameter to the setter, it will copy that parameter in a new memory location. So if you change something in that copy, the one that passed you in the object won't see the change. You made a copy. So like in Java, if you use dates, it's better to make a copy of that date before you use it in an object. Well, this is used in Objective-C as well. Just add copy to your property, and it will be copied for you. Okay. Then retain and assign, I'm going to skip, because you won't need it anymore if you do Arc. But that are the old properties to set. So we just skip them. Atomicity. So in a thread-safe environment, normally all properties are atomic. That means that the runtime will make, every time you call a setter or a getter, it will take a lock on your object. And it will release the lock again when things are done. But of course, obviously, since every time you call a setter, you will create a lock, that might not be as performant as you wish. So most of the time we put the non-default non-atomic. Strangely enough, it's not the default, but we will put the non-atomic there. So let's apply this on our person object, shall we? So again, switching to Xcode. Okay, so I already have my properties, but actually what I did here, the default, is atomic, read-write, and weak. This is not what I want. If the name is passed in, I want to maintain the name just as long as this person survives. Yeah. So what we will do is we will make it non-atomic. No, I put it in the wrong place. It's behind the property, obviously. So non-atomic, and again, Xcode will help me a great deal here, and strong. And I will apply this to all others. So that's easy. I can just copy-paste it in, like this. This makes a very dull demo, I know. Okay, and then what we will do is, actually this full name method here, this one, that's not nice, right? Why not make it a property as well? So let's make that also non-atomic, read-only. There you go. With read-only, you don't have the strong and the weak. That's logical because you don't set it. And strong and weak are only impacting the setter. So you don't need strong or weak there. And what we will do is we will call this also the property full name. And obviously we will remove this one. Yeah. So then, also to showcase you, again, the getter and the setters are automatically generated. So I can use it just as is. So if I would love, and I don't see why you would do this, but if you want, you can also call set name and pass in the name. Wait. Like this, okay? That's the same thing as the line below, yeah? Same thing. I don't see why you should use this, but there are developers that say, yeah, but I don't like the dotted notation. Then okay, then you don't use it, but I like it, so it makes my code more readable. So I'm just gonna use this one. And now for the full name, I don't really have a full name property. So that's okay, this is calculated, it's read-only. So I make the method myself. If I skip this, it will always return null because I don't have a full name somewhere. Yeah. So we will extend this later on if we look at the variables, the instance variables. But so full name we will calculate ourselves in this way. But we will still improve this one. Okay. So that's adding properties and their attributes. So let's go back to the presentation. Pointers. Who knows about pointers? Who forgot about pointers? Yeah. Well, in Java we can. Sad to say, in Objective-C you can't, but normally it's not that big a deal. You just need the little star there and everything is happy and done with. So what is a pointer? Just for those that forgot, what is a pointer? A pointer actually holds a value to a memory object, to a memory address, to an object. So we have this pointer here and it points to an instance of NS object. And because it's pointers, you can have multiple pointers pointing to the same object. If you change something in that object, all these variables that point to that same object will see the change because they point to the same thing in memory. Yeah? So that is, in very short, explained what a pointer is. And this is a large discussion in the Java world, but like in Java, and I'm not going to make mistakes because I looked it up, in Java everything is passed by value because actually in Java you still have pointers. You don't see them as a developer and you cannot maintain them as you can do with C, but you still have pointers. So every time you pass a variable of type object in a method, to an object, you pass it by value because you pass the pointer. Meaning that, again, you create a copy not of the object, but of the pointer. And this is what pass by value is. Pass by value means you only pass the value, you don't pass the reference to the object. So that's pass by value. So again, this is passing in copies. You can manipulate the copy of the pointer, and that's important. Not the copy of the instance, but the copy of the pointer is passed in. So if I change something in my method on the instance itself, it will reflect in the caller. Yeah? So how do we avoid this? In Java, we can't. In Java, you just have pass by value, and you have to live with the fact that you have only one return value. Yeah? Because pass by reference makes that you can have multiple return values. It's not noted as a return, and this might look weird, but what we can do is we can actually make a pointer to an object. This is complicated, right? So a pointer to a pointer means that we will point to a memory address, which point in its turn to the memory address of an instance. So if we pass this pointer in, what will happen is it still gets copied, but only the first pointer. The second pointer, we still reference to that pointer. So basically, if I now in my method change the reference to that second pointer, it will also have changed because the pointer in my callee is pointing to that second pointer. You will have effectively changed the instance as well. So with a pass by value, you cannot do this. If you change the reference, the caller won't notice because you passed in a new pointer and it's copied. So you get this? More or less? Why is this important that I still, in an introduction, this is hard, right? But I felt that I needed to explain this, and I will talk about this slide later. I will first take this one. Exceptions. You have them in Objective-C, so you can do throw and catch and finally. You can all do that in Objective-C, just like in Java. A little bit different notation with the add, but for the rest it's all the same. But they strongly advise you to not use this because it's sorry for my French, it's sucking in the department of performance. Yeah. So throwing exceptions should only be done in really, really exceptional cases. Not like in Java where you can just do this and it's okay. Well, not in Objective-C, but we need an alternative. And this alternative is NSError. So again, a class coming from Foundation. And what we'll do is we will use this double pointer so that we can really change in our method the object itself, and that will reflect in the caller of our method. We will see this in an example. We will read in person from file. You will see a lot of new code. Just take from me. This reads a person from an XML file. Well, it's pretty aligned to Objective-C, to iOS actually. It's a plist. Who knows a plist? People working on Mac might have come across them. Well, it's an XML format used to have property lists. Yeah. So we will read in person, so Sheldon and Leonard, we will all read them from a file, and I will add that code now. So this is basically a big demo on reading from a file. So what we will add in this demo is, yep, there we go, is first of all, I want to be able to create a person. And since that will return a person, I will again make a convenience method. Let me copy paste the first part, because that's also a convention, by the way. You start your convention method with the name of your class. And then it's clear. So, and a string does the same, right? It says string with format. So here as well I will do string with contents of file. Contents, let me type that right, contents. If you see typos, please do notify me. So with contents of file. Let me see if yeah. And the file is just a path that we will pass in. And now we will do this very specific thing. We will take care of errors, because if we are reading files, things might go bad, right? So if we are reading, we will now use the double pointer to errors. Yeah. So this means that I can not only return a person, I can actually also return an NS error. That's how you need to read this. Forget about the pass by value, pass by reference. Just know that this method actually has two returns. The main return should be a person, But if errors occur, an error might be returned as well. So now let's implement this method. So again, I will let Xcode help me with this. And for people that notice, there's this auto-releasing thing. This would lead me too far in this introduction, but this has to do with Arc doing the memory management for us. So again, I don't need to do anything, just leave it there, it will work. Yeah. So NS error, how do we fill it up and how do we read the person? So in Objective-C, in Foundation, you have this class NS Dictionary, and this is exactly the same thing as in Java, a map. So NS Dictionary is a map, key value pair. So I will, and on NS Dictionary, there is a convenience method to read a plist into a dictionary directly for me. So let's use this one. So I will create an NS Dictionary. I will call it person dictionary as a method, as a variable name, sorry, person dictionary. And this person dictionary is read in from a file. So again, this is dictionary, and of course, again, with contents of file. Yeah, convenient. I don't read the file myself. I let Foundation do it for me. So this is convenient for me for this demo because things go faster this way. So now I have this dictionary, and what the contract for this class, you can read it in the documentation. It says that if it cannot read the dictionary, it will just return nil. Most of the cases, if you can expect errors, the default return type, if an error, is nil. So I have to check if person dictionary. Then I know, okay, the file was read in and everything worked okay. So I can start making my person, and otherwise it failed. Yeah. So this otherwise I will do first. So I will say, okay, first off, let's check if the user prepared an error, because obviously you pass by reference, so you will need to prepare the error object on the calling side. So let's first check if the user has passed in an error object for me to fill in. And then I will create a new error, and passing in this case, is just a memory address. That's important as well. So NS error with domain. How do I know this thing? Well, I've been doing some iOS for quite some time, but all is well documented like a Java doc. You also have a very nice documentation on the Apple side. So on NS error, again, we have a convenience method to create an error, and you will need a domain, so I will just make it person domain. You can choose this. This is a way of making your errors unique. Yeah? So this is like in Java creating an exception yourself, an exception class. Let's say that the code is minus 100, so again you can choose this, but I prefer to make them negative because it's an error. And then this asks for a dictionary as well. So this is extra information, so you can piggyback your NS error with extra information. So let's use this, and now this is new syntax for those of you that did Objective-C for quite a long time. Since Xcode 4.4 we have shortened annotations for making dictionaries. So instead of doing NS dictionary with, I now can do at and then the braces, and now I can just do comma-separated key value pairs. So for instance, I can say, let me check, reason. So let's give a, not reason, but reason. I can give a reason and then the colon symbol, so the key is my reason, and the value will be, well, could not read file, person from a file. Of course I can extend this, but for the demo this will do. So that's how we create a dictionary. I am missing something here. Let me check. Yeah, obviously, error is a double pointer. So I will need to dereference this one. This is the slide I skipped. But NS error is a double pointer. So what I really want to do is I just want to put the value of that second pointer in. So I will need to dereference the pointer. This is very specific. Probably you won't need this in your first few applications, but I still wanted to mention them. You can come back to parlays and look again at the talk. Maybe then you will understand better since you have some more hands-on. So This is how I take my error. Obviously, I need to still create my person. So let's first provide a person object to fill in. And I will start with making it nil. Because again, if an error occurs, I will return nil. So I just can return person, right? So now let's create a person. And why not use our own class to do it? So again, I will use the convenience method to create my person with name and last name. Yeah? And what do I need to pass in? Again, very convenient since Xcode 4.4. I can use the person dictionary, and then I can just use the array notation to get me the key I want. So my dictionary contains, so my map contains key value pairs, which holds information about my person. So I can just fill in, this is the key, and it will return me the value. This is very short syntax. Believe me, before 4.5, our syntax was much larger to do this. Now I can just do this in a few lines. So that's nice. So here we will put last name. I have to make sure I don't have typos because my demo will fail miserably if I forget something. So let's also read the real name. And again, I will now just copy paste in things because it's always the same thing. So in here I put a real name, and now let's just copy paste in everything else I need. A few of these, and then let's see what do we still need. The profession. We will also need the bio. We will also need the image name, the identifier. Again, sorry for the dull demo, but I wanted to let you see that you can easily make an iOS application in just 150 minutes. So let me just now copy paste in. So anybody having problem with this code? Is it clear enough? Can you understand the concepts? Obviously you won't be able to do it yourself yet, but do you understand the concept? So we are reading in a file. That file gets translated into a dictionary, and the dictionary on its turn gets translated in a person object. Okay? So this is making the person, and it will return in the end. So very fast how you read in the person file. So, and how you report errors back to your users. We will back to your users. We will use this code in the remainder of the demo, so don't worry, you will see it live. So let me first switch, because otherwise you won't see. Back to the presentation, it is. So now let's look at the ID type. We used it in the initializer. Well, actually, what ID is it's a pointer on itself, a pointer to anything. Again, stating the dynamic nature of Objective-C. So what an ID means, it's actually a void pointer. It's something in C, this would be void pointer. But to make it short, they just chose ID. That's why, by the way, in my person, I don't have an ID, but I have an identifier. ID is reserved, so I cannot use it. So that's why I call it person.identifier. And ID means any object. And this is, you have to take care of your ID variables, because the compiler, once it knows a certain method on any class, it will never complain if you call that method on an ID-typed variable. So there's no real type checking anymore. You won't be safe. So do make sure you know what you are doing if you are using ID. Yeah? For now, you will only need it in the initializer part, so do it there. But know that if you are saying ID, you say as a developer, I take full responsibility for what I do with the variable. Compiler, leave me alone. Don't complain about anything. Yeah? Well, it will complain if it doesn't know the method at all. But for instance, if I have this ID variable that points to a person, and I call this dictionary method on it, it will fail at runtime. You won't see at compile time. Okay, so this is something to take care of. Now let's look at flow control of your code. We used already the conditionals. It's exactly the same as in Java, with exactly the same operators, with exactly the same syntax, so I can skip this one. The for loop is the same as in Java, except for the for each loop. Instead of using for colon, you use for in, but it does exactly the same thing, so you can iterate over everything that's a collection. We will look into collections later on, but we have NSArray, which is an array list more or less in Java. NSDictionary is a collection as well, so you can enumerate over the keys, for example, of your dictionary. Then while and do while exactly the same as Java, so you can use these as well. Now let's look at instance variables, because for now we have been using getters and setters, but we didn't really see how to define the instance variables. Well, actually the synthesizer does that again for us. So that's method number 1 to declare instance variables. They get automatically generated if you have properties. But there are some other ways to do it. So for instance variables you can use private, protected and public in your header file. So you can define them in your header file and make them private. But this is, since a few versions ago of Xcode, this is not used anymore. If you have something private, hide it in your implementation. There are ways to do this. So hide the fact that you have an instance variable, just like in Java. Okay, if you note them private, they will be private and nobody can use them, but still people will know that it is there. And that is, in modern Objective-C, it is a bad practice to do that. So basically you can almost forget about the private. The protected still serves its cause, because subclasses will be able to use the instance variable. And public, we know that this is a bad practice in the object-oriented world, so don't use that either. So there's no package private, logically, because we don't have packages, right? So declaring instance variables, we can do this in 4 different ways. The only one I will use is when we define properties. It will automatically make one for me, and when I do it explicitly, I will do it in a class extension or in the implementation part. You can also do it in the add interface part, but that really only is, since we will skip all the rest, only for protected properties. So what you do then in the header part is you define the instance variable and you annotate it. Well, it's not really an annotation, but it looks like an annotation. You set add protected, and that's it. So let's now see how we make this instance variable work with our full name example. So let me switch back to Xcode. There we go. So this might strike you as maybe not that good practice, because each time I ask for the full name, I will recalculate, I will remake a string. So maybe we can improve. Yeah? So we will try to improve by, first of all, and this is, I'm going to show you the different ways of making a full name instance variable. So in the header file, I start with braces. Accolades is Dutch. So with braces, and in the braces part, I state private. I want to make it private, so I can do add private, and then a string full name. But since it's private, this is a convention. Again, since Xcode 4.2 now, you should use underscore for private variables. In this way, it's directly clear that this is a private variable. Also, if you use self.fullname or something, you will know that this is the property, not the underscore part. So that's nicer as well. So this is method 1, but since this is in my header file, this is visible to everyone that uses my header file. So I don't like this. I'm going to remove it. Well, I'm going to take this out. I'm going to remove this one. And I will move this part to my implementation file, actually making it private and hiding it from the outer world. So what I can do is I can do the same on the implementation file. In the implementation file, after my class, again, I can put braces, and I can just say I have this and a string object full name. Again, underscore in front of it. So now I can use this full name only in my class, and nobody will see that it's there. Okay, so I've hidden it for the exterior world. So obviously, since I have this method, I will then return this instance variable, sorry. Since I have this variable, I will use it in my getter. I will just return full name. And what I will do with it, well, simple. I will override, and this is again a demo on overriding the default behavior of setters and getters. So I will override the set name, and again, Xcode is helping me out. So set name. And then I will do a small check if the name that is passed in is not equal to, and not equal is just the same as in Java. Here I'm comparing memory addresses. I'm not comparing the contents of the string. If the contents of the string have changed, well, I will copy anyway. But if the instance is not the same, I can say name equals name. So underscore name is my instance variable, making it clear again with the underscore. And the name is the variable that is passed in. And now, obviously, I need to recalculate the full name. And my bad, but I will need to repeat the code for it because I just removed it. I didn't copy paste it. So we will now again use this and a string with format. Again, using this very weird notation with self.name. You could as well use name here, but I like it this way. By the way, sending messages, so calling method, sending messages, is not an expensive task. So you don't have to worry about, oh yeah, but don't I need to use the instance variable instead because it's faster? Well, you're not gonna see a big difference there. So go ahead and use the self-dot notation all the time. So I will do the same for the last name. Wait, that didn't turn out like I wanted to do it. So let me do that again. Yep, that's better. Set last name. Of course, I'm going to change the parameters to last name. And I will use this one. And of course, obviously here, I use last name as well. And that's it. So I improved a bit my code, but this is merely to show you that you can have this full name variable anyway. Yeah? And basically, we don't need to explicitly define the getter anymore because it's a property. It's read-only, so it knows. And automatically, I get the full name variable as well. Yeah? So that's all automatically done for us. Okay. There we go. Again, switching to the presentation. So I promise you from now on it's going to be more interesting because now it's only code, it's nothing visual, and we're doing iOS and that's all very visual. So from now on we will start making interesting stuff. For those of you that stayed, great job. Okay, so understanding the Big Bang app. So you already saw the demo, but the Big Bang app, if you want to get to know the code, you have to see the main principle of Cocoa and Cocoa Touch. And again, like almost every object-oriented framework I know of, almost all of them, they use MFC. Who doesn't know MFC? Great, everyone. That's good. You didn't dare, eh? Yeah. So model view controller, and with that comes the delegation pattern. So we will see that, and we also have actions. All this is made to separate your code, the controller from the view, and the model, all nicely separated in building blocks. So MFC and Cocoa, how does it look? Well, first of all, you have the controller, the model, and the view. No surprise there, but they're well separated. So in regular model controller and view, you will regularly see that model and view are still connected to each other. Well, in Objective-C, this is, well, in Cocoa, this is not the case. So the controller will get the data and will feed the data to the model, but the model will not report directly to the view. You can do this, but you are strongly advised against it. So just do all communications with your controllers. Your code will be nicer that way. So after the controller populated the view will notify the controller, but in a loosely coupled way, so the view doesn't know its controller, it knows its delegate, and the delegate can be anything. It doesn't need to be a controller, it can be anything. But most of the time it's the controller. And what the view will do is it will call methods on its delegate to say, for example, I will present myself on screen. Or should I do something for you? Or do you want me to hide it? Or do something for me. Yeah? So that's delegation. And then the last step is we also have this notion of actions. And what that does is when the user clicks in a view on a button or something, well, actually, we will not call the controller again to make sure that we have separated the code. We will just fire an action, but it's not really an event. So guys used to event-driven handling application events. This is another system. You will actually call a method on the controller. Yeah? So that's a target. We call it a target. And again, a target might be anything. And this works because, again, Objective-C is a dynamic language. So basically, you can use closures. Very short explained, you can use closures to say, call me this method on that object. Or in Java, this would be done with reflection. Yeah? So those are the systems behind everything we will do today. So now let's take a look at inheritance in much more detail. So we already saw that we extended from NSObject. So like in Java, you can only extend one class. So that's the same thing, only the notation again is a little bit different. You just put a colon. You don't put extends, that doesn't exist, okay? But you have to put it there. If you don't, you are actually making a root class. So a root class doesn't inherit any behavior, it's really a root class. So you can make them in Objective-C. Again, stating that Objective-C is really, really a dynamic language that you can extend as you wish. So if you want to add a root object for one or other reason, go ahead and do so. But normally, NSObject is more than enough, or any of its subclasses. Okay, NSProxy is another one. I will not talk about that too much, but it's there for completeness. Protocol definition. So to define a protocol, you don't have an interface, you say add protocol. So this is the Java interface, right? And with protocol, you can state, okay, the name of the protocol is my first protocol, and then you can again inherit behavior, or contract, I must say, from other protocols. And again, like in Java, you can have multiple. So in this case, we extend our protocol from NSObject, which is a protocol as well as a class, so be careful there. But so normally your protocol should extend always NSObject. And then you can comma separate the other protocols. So in this case, we have some other protocol as well. And then, as I said, you can make things optional and you can make things required. So if you want to make them required, you put add required, and what follows is are required methods. What is optional, you start with add optional and then the rest of it. You can remove the required. You don't need it. Everything that's above the optional is required anyway. So then to adopt, I don't say implement, I say adopt the protocol. To adopt the protocol, you again use these angular brackets or chevrons or diamond syntax, but don't mix this with generics. It's not generics, they don't exist in Objective-C. So be careful there. Don't think that this is an NSObject that takes my first protocol or something. No, that's not it. So this is adopting a protocol. Now let's look a bit at, now we know exactly, I think this is the last slide of theory for Objective-C stuff. Now we know the syntax. Now let's look at some implementations that are already provided for us, and let's look at the application delegate. Why do I take this first? Because this is basically the delegate, and again this is a delegate, so the application is not the same as the delegate. Your application will notify your delegate that something has happened with your application. For example, in this case, we have a method did finish launching with options. So if your application is starting, Once it's finished starting up, it's loaded in memory, it will send did finish launching with options to your delegate. Same thing goes when your application goes into the background. Then it will resign active. So it sends a message to your delegate stating application will resign active. If it becomes active again, it will call the application did become active. So again, here you see the strongly named methods doing the job. It is practically self-explaining what it does. So these are your hooks to react to application events. And I find it difficult to talk about events in Objective-C because we use delegation and we use actions. So if I'm saying event, I actually mean we call our delegate, okay? So let's look, actually the project we created already has an application delegate prepared. So if you create a new application, an iOS application, you will notice that Xcode, and let me close a bit what you don't need to see, you will see that an app delegate is already created. And as you can see, the app delegate actually extends UI responder. Don't care about that one for now, but it implements, or it adopts, I have to say, it adopts the UI application delegate. This is a protocol, okay? And on that protocol, all methods are optional. So the framework will make sure to check first if you implemented the method. If you didn't, it will not call it. So that's safe. The only thing you need to do is if you create your own protocols with optional methods, you will have to do the check as well. Okay? But in this case, it's provided by the framework, so it will do it for us. And it also creates this property window. Well, the window is actually that blank screen you saw when I started the application. So let me start it again. There you go, the blank screen, that's the window. So this is the window. The rest is iOS specific, so you cannot touch that. That's the status bar, that's your operating system's responsibility. You can notify some things to it, but you cannot really manipulate it yourself. So the window is really the white area you see on the screen. So, and then in the app delegate, we have some methods that are already paired and that make sure that actually my window is made visible. You will see later that I will remove this code. Yeah? We will use another technique. But for now, so when the application is finished, it will prepare the window and it will put it on screen. And it returns yes, meaning that, okay, the application launched successfully. If you return no, the application will quit automatically. So here you can do initialization for your application, and if preconditions aren't met, you can skip the start of the application directly. This makes your app crash, or makes it look like your app crashed. So use it sparingly, okay? And then the other methods, we will not use them in this session, but I wanted to show them anyway, is the application will resign active, the application did enter foreground and background, become active, and will terminate. So on termination, you can clean up some resources or things like that. So in this case, we won't be needing them, so you can throw them away, you can leave them there. Like I said, it's not expensive if the method is called, it's just a tick on the processor, so you can leave them in and fill them in later on. If you really want to do it cleanly, just remove them and add them in later. It's up to you. So that's the app delegate, and now we saw also that this app delegate, again, uses a protocol to do the job. So somewhere our application only uses this protocol, loosely coupling my implementation from the actual UI application. So that means that I can create my own app delegate. It doesn't need to be there in the UI kit framework. I can provide my own. Now, where does this all start? So you know, okay, I have this app delegate and it can have a method that says it did start launching, but where do I trigger the launching? Well, just to make it complete, let's look at the main. And like in Java, the main is the entry point. So we have a main.m file. Don't touch it, leave it as it is. But here you can see that we are actually creating a UI application and that we are passing in via a strange way, but we are passing in the application delegate we created. So the app delegate, and we import the app delegate, so it knows the app delegate. That's how we wire things together. This is all generated for you, so normally you don't have to look into this code, but I just wanted to show you so that you know, okay, this is where it starts. So the main method, and then after everything is ready, framework-wise, it will call you to add extra stuff that is application specific. Okay? So switching back to the presentation. Now let's look a bit at base classes that we find in UIKit. So you will see a lot of classes starting with UI this time. Yeah. So we have the UI view controller. This is the main controller class you need in Objective-C in iOS to listen to things on your view and to talk to your model. So this is the entry point, and there's a base class for this, the UI view controller. So again, this provides already a delegate for you. Yeah. You can override these methods. For instance, you will have the view will appear or the view did appear. So again, things first need to get loaded in memory before it shows it really to the user. But right before it shows it, it gives you a chance to still do something. So you can hook yourself into that process with a view will appear. And actually, what happens the first time the view gets loaded, it will first send the view did load, and then the view will appear. And on every executive call, if the view still exists, the view did load will not happen anymore. It will just be the view will appear. Yeah? So these are all delegate methods. You have to learn these from the documentation. Yeah? So for each screen, and really guys, important to see, for each screen in your application you will create one. Not for subparts. You can, but you don't often need this one. When I started out with Objective-C, I made this error quite a lot. I tried to make controllers for every little button that was already on screen. Well, it's not needed because the controller is already in the framework for the button. So you don't need this separate controller. Just make a controller for each view, and with view I mean the complete window. So make a UI view controller for each screen you have. Yeah? So this is also the place where you add these actions. So you know the arrow that was flying up. This is the place where normally your arrow lands into. So you will create a method in a specific way. I will tell you how. And that method will be called by your button when it gets touched or tapped. Yeah. So it manages a set of views, not just one view, but there will be a parent view. And then you will have a hierarchy of other views inside of it. So a specific case of this view controller is the UI table view controller. Like the word says it itself, it's a view controller that manages a table view. So this is a very specific view and a nice view, largely used in the iOS environment, where you create actually a table view for your data. So this is to present a collection of data. And in that table view controller, actually there are two delegates. There's a data source and there's a delegate. The data source is to provide data to your table, because you will see it will only ask for the data for the visible parts of the screen. It will not ask the entire data set at first. That's not needed. Only the data set that is on your screen. It's mobile, so it needs to be performant. If you load 2,000 records directly in your view, it's gonna crash. You don't have the amount of memory for that. So a data source actually manages this for you. You just need to provide one record each time. Yeah? What does the regular delegate do? The delegate reacts on touches. So if you touch a row, it will send again a message. It will respond to that message. Yeah? A table view, furthermore, is divided in sections. In this demo, I will only have one section, which is the default. And then in each section, you have rows. So that's a table view. Yeah? So for showing this data in the table view, we need a data source. And the data source delegate will also not only ask for the data, but will also make the cell. So if you look a little bit more closely to the screenshot there, each cell actually also is made by your data source. And your data source will return a UI table cell, which is a view. It's just a regular view, but it's a cell for a table. So the two main methods that you need on a data source, so again, data source is a protocol. The UI table view data source is a protocol, so we will implement it or adopt it. And these methods are required. Those are the only ones. The rest of them is optional. And in this demo, we will only use these ones. Well, we might end up using more, but I don't think I will have the time. So for this time, it suffices to show you the number of rows in section. So this is really to tell you, in this section, I have this many rows. Yeah? So it knows how many cells, in the end, can end up in your table view. And then the second method is self for row at index path. This is where you create your cell, and this is also where you put the data in that cell. Yeah? So that's the table view self for row at index path. Yeah? Again, Xcode will help you a great deal with generating this code, so don't worry, it will be there when we start generating this. So let's do that now. Let's create our master table view controller. So this will hold our list of persons. This will be quite a demo. So, and then after that demo, I will give a short break. I think you're up to it. I think you're up to it. So let's again switch to Xcode, and let's start by making this new class. And this time, I'm going to create a controller group. Again, I'm responsible for making a good code base. So let's do it. We will make it controller, and we will create a new file in it. And that file, again, is just a regular Objective-C class. And we will call it master table view controller. Well, actually, let me show. If I just type master table, and then I extend from UI table view controller, it will automatically put the view controller behind it. So less typing for me to do. So master table view controller, this is what I want to create. The rest I leave open. Again, come to the session this afternoon if you want to know what that means. And then we will create it just like we did the other class. And let's first look at what gets generated. Well, what gets generated is the master table view controller class, which extends from UI table view controller. And actually, this automatically adopts already for us these two protocols, that UI table view data source protocol and the UI table view delegate. So these get already implemented, so there's default behavior there, but you can override. It's safe to override. And actually what we see in the implementation file is that it already implemented this view did load for me, so this is an excellent place to initialize our view. And it also generated the number of sections in table view and the number of rows in section. Well, actually, the number of sections in table view, so this is the number of sections, not the number of rows, the number of sections, I don't need it, so I'm going to remove it. Because by default, there's only one section. And this is dangerous code that it generated, but because by default, it returns 0. So even if my entire code would work, I wouldn't see anything, but because you provided 0 sections. You at least need one to show data, so just remove it. Or adapt it to something else than 0, because you won't see anything in your table view. And then this method I will need, I will fill it up in a minute, but this is the number of rows in section method, and then this is the self for row at index path, with already some code provided to me. I will explain this also in a minute. So now let me first check if I still need to do something now or later on. Almost there. Yeah, I will need everything now. So now, how are we going to present this data in the table view? First of all, we will need a record set, if you want. So what we will create is I will create, and this is very specific. I didn't explain you this, so I will not use it for now. But this afternoon, I will go into this in more detail. What this is, so just skip it for now. So for now, I will create an NS mutable array. So this is an array that I can adapt. If I just use the NS array, it's immutable. So I will need the mutable version for now. So let's create an NS mutable array. This is an array list in Java, just the same thing. And let's call it persons. So this is private again, it's not visible. So I create the persons array. I will read this in later. I will first show you how we are going to use this. So take for now that this contains our data already. So what we need to do then is, instead of throwing this dirty warning here, we will go and remove it, and we will not return 0, but actually we will return the persons.count. This is the same thing as the length method in Java, but here I can use count. Again, this is a property on NS array because I use the dotted notation. So by now it should be clear for all of you. I use a dot. If I use a dot, it's a property. So persons.count is a property on the array returning me the amount of records in my array. So there we go. We will already see some lines, but in those lines we won't see much data. And that's this method here. So let's study that in more detail. Actually, first of all, we make a static NS string. Again, skip this for now, just take it from me. This initializes a static variable in the class. It's very specific C syntax, yeah, but this makes a static variable, which will be only defined once for my entire class. This is how you do that in Objective-C. Different syntax, but same idea than in Java. And to make it more beautiful, let's make it a person cell. And what does this thing do? Well, it's an identifier. You can pick it yourself, but you should reuse the same identifier over and over again. Because what Objective-C does, what I have to say code touch now, so what that does is, you have normally, if we go and look at the screenshot, you will see that you only have 8 or 9 lines, depending on iPhone 4 or 5. You will have a certain amount of lines visible. All the other cells that are not yet visible actually are not created yet. He only creates them just in time. And what it also does is, when a table cell moves out of view, it will put it in a queue, in a dequeuing queue. So it will disappear from screen, but the actual object, the actual view, will not disappear. It will just be maintained in some kind of pool. And later on, when a cell reappears, it will dequeue that cell, and then you can reuse it to populate it. This might come bizarre sometimes, because if you don't set certain properties in certain cases on your cell, you will still see all data on the cell. So that's the main thing. Always set all your properties, all your data on your cell. Even if you think, well, this couldn't have changed, change it anyway, because you are dequeuing cells. And since Xcode 4.5 and iOS6, the dequeuing mechanism has improved largely. In the early days, we still had to create our own cell when it wasn't able to dequeue. Well, now it will do the dequeuing automatically. So this is all the code you need to dequeue your cell. And if it cannot create a dequeued cell, so basically you come on the view, then nothing is in the pool yet, it will automatically also create the correct type of UI table view cell. In our case, this is the default, so UI table view cell. This is the main class for doing things in a cell. And what we can do on this one, so as I didn't already mention, but with the method came an index path, and this actually contains the row that it is asking. So you only need to have one cell with one set of data in it. So let's go ahead and use our person here. And actually, to use that person, I will first need to import the person in this class. So let's do that first. Person, let's make no typo. So now I can use this person class. Again, only the visible part of it. And that's why I've, for example, hidden the full name thing. Yeah? I will not be able to use it directly. Well, I can, but I shouldn't. So the compiler will give me warnings, so don't ignore warnings in Objective-C. In Java, you can still ignore some of them, but in Objective-C, that's a big boo-boo. Yeah, you don't do that. You don't ignore your warnings, you fix them. Skipping back to the configuration of my cell, what I will do now is I will first fetch my person, and I know my person will be, so just I call it person, my person will be in that mutable array I created. Yeah. So again, we didn't fill it up yet, but we can already use it. So the persons, and again I can use a short notation, an array notation for this. I don't need to call a method. I can just say I need a person in a certain index. Well, the index is in my index pod, so basically index pod contains a row property. So I can ask for that row, and this is the current row that the framework is asking from me. So I will get the person from there. And then if I have the person, now I can start putting data in that cell. So now, this is code that I didn't explain yet, but it's very easy. A cell has actually two properties. It has a text label, and this is the one we will use for our table. And in that text label, this is a UI label, it's a view. And in that label, I have this property text. So I can put the text, and what will I put in? Well, I will put in the person.fullname. Yeah, that's it. My data is created. And of course, afterwards, I need to return the cell. So that's all you need to create cells. Now, for the difficult part, I obviously need to get some persons in that array. That I didn't do yet. So what I will do is I will first start with a private method. And private doesn't exist, I told you, but invisible. So if I say private method, I mean invisible. And what we do in Objective-C, we regularly do pragma mark. Actually, that helps Xcode locating things. So I call this pragma mark private methods. And actually what that does is now you will see here that I actually have a category in my code with private methods in it. So I can make this myself. Little demo. So what I will create is a private method that will return me a person, and I will say read person. Let me have a quick look. I don't know this by heart. Let me have a quick look how I prepared that one. There we go, it's here. So actually I called it add person from file because it will add things in my NS array. Again, passing in the path. And what that thing needs to do is, first of all, I will read a file from the resources of this application. So, like in Java with resource bundles, who knows resource bundles? All of you, obviously. So in the person part, you read in, wait, that's not the one I wanted. You use an NS bundle, and this is actually your application bundle, main bundle. This is the one. And then part for a resource, and then you pass in the resource name. And in this case, this will be the person that I want. So actually, this I will change this to name because here I will pass in the person name. So if I want to read Leonard, I will pass in Leonard. So here I put in name of type, and this will be my plist. So this is, wait a minute, going not too quick there. Okay, so this will be plist. Now, where does this come from? Well, I will show you. I have prepared these files, luckily, otherwise it would be a very dull demo. So I have prepared some person files. Here you will see these 5 persons that will appear in my list. So in Xcode it's very simple to add files from somewhere else to your code. I just move them into wherever I want, but in this case I like them in the supporting files section, and I also copy them in. That way I automatically create a copy in my folder. We will do this a lot this afternoon. And to let you show this dictionary, you already know that this should be a dictionary. Actually, you see here we have Howard as ID. His name is Howard. His last name is Wolowitz. His profession is an aerospace engineer. Should have picked another one. And then the real name is Simon Helberg. His bio and his image name. So he doesn't have a website, but that's okay. Yeah? Who has a website? Well, Leonard. Leonard also has the website property. So this is what we will read in. So now we have the person path. We can go ahead and actually use this path in our method we also already created on the person. So now we can just say return, because we want to return the person with contents of file, and the file is the person path. And obviously I want to report errors, so I will pass in an error object, again very specific. I will create the NSErrors variable. So this already allocates memory in the stack. So I didn't create an instance yet, but I allocated some memory in the stack. I allocated memory for the pointer. So, and then I need to pass, since it's a double pointer, I need to pass the address of that pointer. So now I have read the errors. I'm not doing anything with it to shorten the demo a bit, but I could put some UI alert view to notify the user that a person didn't get read in. And obviously now I have this private method. In my view did load, we know that this is the first time that the table view gets loaded. I can now say persons add object. That's the same as the add method in ArrayList. It's just called add object. And we add in our own result of the add persons from file. And let's say that we first want to have Leonard. There we go. And we repeat this. I agree this isn't very good, solid code. First. But it serves the purpose. So let's also include the other 5. So we have Sheldon, we have Penny, we have Howard, and now very difficult, we have Rajesh, Kutrapali. Yeah. So let's run this. It will be disappointing, I'm telling you. So we prepared everything, but we didn't tell the framework yet that we have this table view. So I still see that we have this table view. So I still see the blank screen. So if it's okay for you guys, I would like to do the pause right now. So take a half an hour and then come back to me for another 66 minutes of iOS fun. We will make the table view appear, okay? See you later.